fine, right? What is the course highlight? As such, I talked about, right? We may be just doing. Give me a second. Okay, so we may learn everything in an extensive fashion, in an in-depth fashion, and in a comprehensive fashion. We will be learning a lot of use cases for business understanding and a lot of hands-on for technical understanding. We just go and say, don't go and say, guys, just do some technical activity alone. We'll say, guys, for this business, what is the technology we are going to provide? How we create the data pipeline? How we are going to implement this business with the help of technology, right? The tool integration we are going to see. We are going to see end-to-end integration, end-to-end system management, starting from data acquisition, transportation of data, queuing the data. One of you asked, right, hey, are you using a message queue, PubSub like Kafka? Even you supported me for, Balamurani is saying, you supported me for PubSub Kafka. I called you a couple of times about a month back. Yeah, fine, Bala. Yeah, okay, right. So you already have learned, right? Okay, fine. So like the support what I provide, just I'm saying, right? So message queues like Kafka, we are going to learn. Transformation, what we do, end-to-end transformation, processing, enrichment of data, lookup of data, streaming of data, persisting of data into multiple storage levels, visualization. We are going to see end-to-end. When I switch on a button in a pipeline, it has to provide me the final visualized the output out of it. That kind of learning we are going to do. We are not going to only learn a piece of information of saying how to transform the data, how to enrich the data alone. This is the part what Spark can cover. Spark knows how to enrich and transform, but that is the major part of our learning which has to be. But we have several other parts. We connect all the dots and say, hey, you know, after you learn this big data platform right altogether, you are going to say, hey, anybody, you are going to say, you know, any data from any source in any speed, it is going to be get generated of any type. I don't bother. I know how to manage them. But right now, you may say, if you are in a database background or in an application development background, you may say, hey, you know, I can handle only structured data. If we define the structure of the data, I know how to handle it and how to store it into a database or into a file system. This is what you are going to say right now. But whereas in the near future, you are going to say, I don't define any type of data. I don't define the type, the storage where it could be. I can put X here, X here. You just put, you can fill anything here or here. I know how to manage. How to acquire the data of any type, I know how to manage. How to transport any data of any type, I know how to manage. How to onboard the data from some configurable tool to an extent of time, I know how to manage. How to transform, apply some transformation logic, business logic on top of the data, I know how to manage. How to enrich the data, I know how to manage. How to look up, I know how to manage. Everything you are going to say, I know how to manage. How to just work on it, right? That's what the part of learning you are going to learn. No, Balamurugan, I'm not going to cover IoT, but we are going to get the data from IoT source. IoT means what I'm going to cover, how the IoT data looks like I'm going to cover, but we are not going to design any IoT system because it is out of our scope. It is all about the source system, how they are going to work, okay? But you will be knowing about what is IoT, how to get the data of IoT, that you are going to see. What is Internet of Things we are going to get, okay? Just give me some time, we'll just go about it. So, data engineering we are going to do, data analysis we are going to do as per the market requirement. Every course are being designed as per the market requirement. Data engineering to an extent of data analysis we are going to do. Aishwarya I have told, right, saying, you know, like they are asking something about the analytical queries, the windowing queries and all in SQL. That is all about the analysis, what I'm going to do. Batch processing, in-memory processing, interactive processing, real-time data processing or real-time data management, column-oriented or document-oriented data store we are going to learn, visualization and dashboard we are going to create. All this might be a new terminology for you guys, right? Don't worry, we are going to learn all this in our near 5 or 6 months of time period. Stable versions we are going to use in terms of software. I will take care of providing an opportunity for installing and configuring softwares provided with the sandbox to you guys. I will be providing you a virtual machine for you guys. What Aishwarya told, right? Whatever the project I did in the virtual machine, that helped me a lot, right? That virtual machine we are going to provide you. We do benchmarking, performance tuning, best practices to follow in the projects and everything we are going to do. So this is the key course highlights of what you are going to learn, not limited to. Just some of them I mentioned over here. The key highlights I mentioned here, but we are going to learn a lot out of this, okay? So this is the brochure what we have shared to all you guys. Whether you guys get a chance to go through with this or not, just I'm telling you, we created the world's first unified course on big data. This is the world first unified course. Unified means a single course that covers Hadoop, Spark with cloud and DevOps powered with RPA, robotics process automation. Right? So you are going to become a full stack cloud-based big data engineer powered with DevOps and RPA. So you are going to touch base with cloud. You are going to primarily going to be a big data engineer powered with some DevOps activities. You are going to do development and operation activity powered by robotic process automation as well. So 5+ years of excellence, what we are providing, 5,500 plus growing student base, right? Technical services, placement assistance, and candidature evaluation services for several companies we are doing. Number one in training to job conversion rate. That means just not as a training you are going to go out, you are going to be converted into your job, like as all you guys are wishing, right? That you can able to get, provided if you guys are going to follow whatever like expectation we set, right? If you are attentive, attention, you are going to be engagement based, and if you are going to follow my instruction and do all the activities what I'm expecting, you guys can simply get your job very easily, right? And you are going to shift, or you are going to fast forward your career, right? 10 years from now, whatever the effort you are going to put 10 years from now, what is the salary you are going to get? What is the growth you are going to get in your career, right? That growth you are going to get just by spending the 6 to 8 months of time in terms of this learning. This 6 to 8 months will help you to drift your career 10 years from now. Think like this, right? Okay. So these are all the technology stack what you are going to cover in a single course, right? The cloud, big data, DevOps, all these are the components that we are going to cover. Fine, let it be. Let's go further our understanding, okay? About this course. So I have just mentioned in this slide itself, okay? Just give me a second. I have mentioned the course content. We have shared you the course content in the WhatsApp group, right? Go through with this course content. You will get each and every understanding of what you are doing. You can't see such a course content design. This is purely designed by myself, right? Of understanding what you are going to do. Everybody design a course content by giving it to somebody, saying like, hey, you design and give it to us, because the designer does not have a clarity of what he's putting. Whatever the content somebody have given, they'll be putting, but ours is a bit different. We created this course content, so I know in and out of what we are providing. Based on what you are going to provide, we are going to, I created this course content. So nothing will be deviated from here. You will be getting more than this. Whatever the course content I provided, it's more than the stuff you are going to learn, okay? So prerequisite, however, we'll take care, as I told you, right? Don't worry, we will take care of bringing it to you, okay? The technology stacks, what you are going to learn, what are all the training model we are going to follow, what's unique with us in our learning, right? What are the key learning activities we are going to do, right? What are the big data ecosystems that we are going to cover? What are the domains we are going to get addressed? All these domains, regardless, what are the domains you are belonging to, you can see yourself here, right? What are the data engineering techniques we are going to see, data lake or batch or in-memory, fast data processing, everything is mentioned in this course content. You start, go through with this course content and in a time being, right? Whenever we cover some portion, you go and see the course content, you'll be seeing more than that. So the initial part, what you are going to learn is overview of big data. What is big data? How it got evolved? What is big data is all about? How it is being classified? What are the size of data that we can deal in terms of big data? Why big data is trending? What is IoT? Why, big data is trending because of all other technologies, right? What are the challenges we face in big data? What are the characteristics of big data? Tools that are all being used to solve the big data problems. All this I'm planning to execute today, right? By spending some time, okay? Some of this I want to execute, some time to make you guys understand. So I've taken most of the time for making understand or get set something related to what we are going to learn, to bring some confidence and to make you guys feel comfortable for the learning of whatever we are going to do further. But let's take like this as an opportunity. So we are going to learn Linux. We are going to do some Linux scripting. We are going to go into Hadoop, and then we are going to learn the Hadoop file system, the data ingestion using Scoop, Hive, SQL layer or MapReduce, Yarn. We are going to see some NoSQL. We are going to see, we are going to see some database on top of NoSQL, Oozie for job scheduling or workflow management. We are going to learn programming platform like Scala, Python. I should have told, right? They asked me question in these aspects, right? In terms of Scala, they asked me what is the higher order function and so on. That is the part what I just mentioned over here. And once you learn one language, Scala, you can simply learn Python. Or if you learn Python, you can learn Scala easily. Like this, you can just very easily learn the technologies. Like you can shift from here to there. But at least one programming you have to know. But these are all function-based programming. You don't have to write 1,000 lines of code for achieving a functionality. All these 1,000 lines are written and kept somewhere else. Your work is to just call those functions respectively. That is what the Scala and Python says. So you don't have to worry much about writing a huge set of code. That will be taken care. So we are going to learn it in a very simple way. Okay. Spark is the framework we are going to learn more in detail. So you see, these are all the key parts what we cover in Spark, which is more in detail. Key use cases what we are going to cover. We are going to learn Kafka. We are going to learn NiFi, Hue, Ambari, Hortonworks data platform, Elasticsearch, Kibana, GitHub, Maven, cloud platform or Google Cloud platform. A lot of value-added services we are going to do, and a lot of use cases we are going to do. Projects we are going to cover. All this explains what you guys are going to do. Got an idea? So it's all about the course content I just shared. So I have everything in my box, like in my hard disk, in my machine, I have all the content which is upfront ready. You don't have to think like I'm going to get it ready when we start the batch. It is already defined and kept ready. I have a lot of contents, documents and everything kept ready for making you teach right in a better way, right? And I will be providing you the parallel learning also. In the sense, I may be sharing you this PDF where you guys can go and learn end to end. So I'm going to share all this as a PDF also, so you guys can go and revisit this for learning what I'm just sharing as a kind of whatever as a kind of a knowledge transfer. So you guys can be able to go and learn the details of what I'm sharing in the classroom. So these are all the stuffs, the architecture and everything. This you can use for later learning purpose. So I will be sharing you the learning materials also. So there are 3 different types of material you can see. One is whatever the classroom session I'm executing with some presentation, that is one part. The second part is the learning material in the detailed way of whatever I executed in the PPT. You will be getting in the detailed in the PDF way, right? Whatever you learn in the PPT. Then you may be doing some hands-on exercises by going into this box. This is the hands-on document what we have. So if you are going to practice in Linux, we will be opening with this document first, and you guys will be executing all these commands in and out. Like this, I have defined all the stuffs in a PDF way, and I provide you several programs also separately in a later point of time. All these are our hands-on materials. What are the hands-on we are going to do, right? All these inside these documents in a well-defined way, right? So if you are going to work in Spark, right? Maybe this is a kind of a preliminary hands-on. We may do a secondary hands-on also. That is with the program in Eclipse or in IDE and all we are going to work. So you see here, this contains every programs in a defined way. How do you work or why you are doing. Some architectural part also it has been added over the Spark core or SQL or whatever it may be you are going to learn, right? You see, it included with a lot of additional discussion, like how this architecture works, how this works in such a way, all this, how the abstract syntax tree works, right? The comparison study between them. Like you are going to have predefined documents, very, very well built documents. We are very famous for that. People used to always say, Irfan, what are the documents, the content you shared, right? That seems to be like very good actually. I'm feeling very much comfortable to learn with those documents in a simple way. Got an idea? So all these documents I have kept ready. All these, whatever the stuff I just shared you here, right? In terms of like the each and every domains we have covered already, right? Everything is available over here, right? In the name of projects or in terms of domains, or you can go to our site also and see all this content, that is also you can do altogether. Okay. I can just show you guys some link over here. If you guys have some doubt, hey, why I have to learn from Inceptus or why I have to learn this big data course, if you guys have some question, you guys can very well go on, get resolved, answered by visiting these pages. We have shared these pages already to you guys, I remember. So what is this learning is all about? Whether you guys have seen or not, I'm just showing you guys. If you want, you can go and revisit this, right? You may have a lot of questions, right? You can get most of them resolved here. I put a calculation here, as such I told you, right? 5 to 10 years, you are going to go fast forward your career like this. You now go and see this page once again, you may get some clarity of saying, hey, what I can get out of all this course, right? And frequently asked question, if you are going to learn this stuff in the online, what are all the stuff you have to be ready, how you can engage this for now in the online session, right? For online training, what are all the challenges you may face, or how you can get answered with all the questions or anything else, right? So I just wanted to address all this. You hope you guys can go and see these sites. We provided that in the WhatsApp also for you, right? And you can go to our site called info@inceptus.com, or I'm sorry, you can go to the site called inceptus.in, where in the more page, right, you can see a lot of pages have been added here. So whichever the document I talked about, well, introduction to big data I'm going to talk today, means that introduction to big data has been added here. You can just go and see that document over here, and we'll be sharing as well. But in the site also we have a lot of content to learn. You can go to our site and learn all these steps. I'm going to talk about what is big data today, right? I'm going to start with that in another 5 or 10 minutes. So we'll go for about 1.5 hours of discussing all those. Then we can just close the today's session, because I want to touch base with some technology learning today. Okay. So this, whatever I'm going to discuss will be there in this document in a more defined way. You guys can go and revisit this document in a later point of time. We'll be sending you this document also, by keeping it in a shared drive. Okay. So that part also we'll be doing. So you can go to our site anytime, and you can just make use of our content over there, just for your information. Now, let's drift to the next level of learning. Let me go into the learning part. Okay. How long we can use the VM post our training? I'm not getting you, Balamurugan. How long you can use our VM, in the sense, this VM is going to be with you. This VM is going to be provided to you as a software. You are going to download it and you are going to have it in your machine. You can use 24/7.
Okay. So post our training also we can use it, right? After 6 months.
Yes. It will be with you throughout your life.
Okay. Thank you.
Always don't say post training, because we treat everyone in the same way. Post training, or you are in the current training, we will be engaged with us throughout your life if you wanted to come back and engage.
Okay.
Got an idea? So definitely that support will be there. You don't have to worry about it. Maybe after training we will be disconnected. No, not really. Throughout our lifetime in our career, we are going to be connected. So don't worry about that. We'll be making it happen. Okay. Fine. So these are all the stuffs what we used to cover, or what we used to provide or promote and all, right? Let us go into the learning part of this. Okay. So I just pretty much covered what all the stuffs, and I wanted to show this one as well. You see here, guys, in the shared drive, whatever I shared you guys, whatever the shared drive Basit have shared you, and you guys have filled this information and all, I wanted all you guys to fill this. Some of you might not have filled. I think like 64 or 60 people are there in this group. I wanted rest of all you guys, whoever hasn't filled this page has to be filled, and you guys keep this URL in your system or somewhere, because you guys will be showing the progress in learning by going and updating this page. I captured all your names over here, whoever have given so far. All you guys are going to do the hands-on with me, and you are going to do some additional use cases. You are going to put saying I completed or not. Got an idea? This is a progress document what you are going to follow. For example, let me show you this.
Irfan, 1 second. Can you paste that link in the group?
No problem. I'll share you this. No worries. Or somebody else in the group also can share. No worries. Okay. So let me show you one more thing finally, guys. Okay. I'll just show this and go into our learning part. Okay. So we keep all this, stuffs whatever we are sharing to you guys in the shared drive, in the G drive. Not only that sheet I'm talking about. I'll show you guys in the G sheet how the people are engaging. The current batch is engaging. So you will get a clarity of how you are going to engage, right? But however, I'll tell you about all this in a later point of time also. You see here the 33 weekend batch, right? They are updating, right? You see here the project update. They are doing it in the other side. You can just see that. Okay, so just see this. These people are engaged by saying, "Hey, we are doing all these activities." Are you seeing yes, no, or whatever it may be? You are seeing this, right? So I wanted all you guys to update here. Though I tell you, somebody might not be updating, or somebody might have completed only some part. maybe updating, that's fine. But I want to see why for all you guys. That's what I always suggest to everyone. But however, that is fine. You can see the use cases, projects they're executing, the Scala hands-on what they're doing, or Spark hands-on what they're doing. Maybe somebody might be lethargic to update this, but this is what the the mutual expectation I told, right? I wanted you to be responsive. I wanted you to be updating or just be interactive. This is what the interaction I'm expecting from you guys. Even including interview readiness, we are supporting. How much you guys are you wanted to go into interview, we'll help you guys. So you can put yes or no here, right? Test how much you have executed. Hackathon, how much you executed. 2 of them have sent, but still they have to update it over here. The competitive learning, we are going to share some use case and we are asking you to ask you guys do some activity on the use case, right? The projects what you guys are going to do, all will be maintained here. You see the projects they have updated. They did 3 projects, right? All this you guys are going to do in your case also. This is the previous batch or current batch stuff. You guys are also going to update all over here. So this is one part. The second part is, you can see here, I created maybe like some shared drive where everybody used to get engaged in terms of all the data sets we keep over here. Some data set what is needed for working in Spark or Hive and all. So we have a lot of data set like like JSON data or log data or auction data, eBay auction data. Like lot of domain data will take and process. Okay, so we have a lot of data set with respect to transaction data, customer data, right? Bank data, right? We'll be taking a lot of country data, like company data, like we'll be taking a lot of data sets for our understanding purpose. I'll be sharing this data set over in the online in the shared drive as well. You'll be having it in your VM box also. Okay, and every PDFs or PPTs whatever we are discussing, right? I'll be putting that in the shared drive as well. Okay, you can see here for Spark, the code I have separately kept, and the these are all in the near future we are going to do. All the PPTs, PDFs, what we have used, I'm just sharing here, right? All these you guys are going to get in the respective locations. And the collaboration, what we are doing, that means I just ask you all to create some folders in this shared drive, and what are the activities you are doing, you are going to keep your activities in this drive. For Scala, what you did, this is the part what this guy have worked actually. The Selvaraj worked on this part and he uploaded what he worked in this collaborative directory, the collaborative location where he is putting. This is the collaboration what we may do, right? I want to see something from you guys. He completed this project. I told, right, several projects we'll be sharing. This is one of the project. I put a complete end-to-end architecture with by plugging the technologies in it. This is a batch project what you are doing. I give you all the information of how to work in this project, what is the data structure. You can't see even a single project in the market that is available to provide all this. We are very famous for that. We provide you 6 projects. If you do 4 projects or 5 projects out of it, you can very well go and present yourself. I should have told, right? It seems, the projects what I have just executed in my VM helped me a lot to promote or promote myself in the interview, right? With a 13 years experience candidate, she is saying like that means for 4 years or 10 years or 8 years or 15 years even can feel the same. If you guys work on these projects and all and update in that sheet saying, hey, I completed this project. No, see, we spend a lot of time to create all these documents and make you guys work on this and all, okay? So you guys are going to understand the customer navigation pattern. You go to online and you do some activity of visiting the home screen, advertisement screen, purchase screen and coming out and all, right? How the activities you have performed. These activities and all we'll be seeing in this project. Customer navigation or frustration scoring we may do. Whether this customer is a highly frustrated customer or a happy customer, or low frustrated or overwhelming customer. I will be doing some frustration scoring and everything. This is a part of one project I'm saying. So this guy have executed 2 projects, it seems. He placed those 2 projects. One in retail, another one is in a insurance domain. You guys are belonging to these domains, right? These domains we have already given projects with the synopsis of how you are going to work and the data pipeline, how you have to create. All these are available. How you have to execute this step by step we are seeing here. Do you understand what I'm speaking here? You are seeing most of the cases you see SQLs here. So SQL is the base understanding that is required and we are going to learn all this, right? So this is about the projects what you guys are going to execute, not limited to. I have around 6 projects to be provided. So all this in the collaborative environment, in the collaborative directory, you guys are going to keep your stuffs. Okay. So these are all the stuffs what we are going to do altogether. So I gave the projects to them, they executed it. And I'm going to share a few more projects to them, they are going to execute it. Got an idea? This is all about the content and everything what you are going to deal with, guys. So let's enter into some learning today. I don't want you to leave you guys without providing some technology knowledge transfer. Let's try to get some understanding of how the evolution of data have happened, how the data got evolved from 1970 or 1960 period onwards. So first, let's try to understand how evolution of data have happened. Evolution of data in the sense, initially people used to manage the data in a kind of a notepad file or in a scratch files, or in they used to put some lines in the walls and all, right? That is how the evolution of managing the data have been started with, right? So how the evolution of data has been started in terms of computation period, right? That I want to first cover. Then all about big data. We have to first know about what is this terminology big data. Everybody is saying big data. What is it all about? Let's try to learn about that one next. Then we enter into the learning of Hadoop, right? So this may take another 1 or 2 weeks for our learning actually. So first we have to set our platform very clearly. First we have to be very clear in the platform. I may go with like a lot of theory part over here. It may take some time for you guys to make you understand some of the theory activity of understanding what is Hadoop, or how Hadoop architecture works, how Hadoop storage works, right? How high availability works, and so on. I want to discuss. Then we are going to do some hands-on in terms of Linux, in terms of Hadoop commands, right? Then we are going to install and configure a Hadoop cluster, and we are going to start working the Hadoop command. With this one, you can say, I'm a 50% Hadooper. In the first 2 weeks or 3 weeks, you are going to say, I'm a 50% Hadooper. As one of you is asking, right? We are going to spend a very minimal time, maybe 1 or 2 weeks, right? To make yourself as a 50% Hadooper, and 1 more week to make you as a 100% Hadooper. So altogether, we are going to spend maybe three weeks of time to bring you to a board of saying, hey, I'm a Hadooper, I know Hadoop. But after that, we are going to learn a lot as an ecosystems of Hadoop. We are going to say, we are going to learn about the heart and brain, first of all, right? And we are going to learn about the organs, right? Spark would be one of the organ, one of the vital organ, I would say. But the key is the heart and brain. So first we'll spend some time on understanding the heart and brain, okay? Let's try to understand. But before going into all this, I want to break the ice of saying how the data has been evolved, what made or what brings the necessity of invention of big data, how the big data has been invented or evolved, right? Everybody of us are getting evolved based on the need, right? Big data also has been evolved based on the need. So how that happened? Let's try to understand that in the name of evolution of data, in the name of big data. I mean, evolution of data, how it evolved till big data. That's what first we are going to understand. Then we are going to know about what is big data, why big data, what are the characteristics it has, right? How the big data is trending, all this stuff we are going to learn. So maybe I'll try to cover to an extent of these 2 steps today. Okay, let's go with it. Evolution of data in the year of 1960 plus, right? People used to have the data generated as a traditional files. Traditional files in the sense what? People used to go and create. One second. So people used to go and create some notepad kind of file where they mentioned saying, hey, the customer called C who approached, he'll be typing in the screen saying who approached a shop called S, and he purchased a product called P for an amount called A of a quantity Q. Like this, I'll be typing a passage of content. Initially, when the computation was started, I open a notepad kind of content and I say, hey, a customer, Arun has come to the shop at 10 o'clock morning, and he asked for a product called, I'm a food industry. So he asked for idli. I provided idli to him, and he just gave me an amount of 2 paisa to me, and with the quantity of 4 idlis I sold for 2 paisa. Like this, the complete content or passage has been written by the shopkeeper to retain that information, to understand what sales he have made or what purchase he have provided to the customer, right? Okay. So Gayatri asked one question in between: is this certification helps get Hortonworks certification? Yes, you can approach Hortonworks or Cloudera, but now Hortonworks is merged with Cloudera, so you can directly get the Cloudera certification. Okay, the certification part, however, I'll be covering you sometime later. But for now, you can just think you will be in a ready state to do the certification. Okay, Gayatri. Okay. So guys, originally I used to write a passage of content. I used to write like a statement or a kind of an end. I mean, I'll be typing it as a passage saying, hey, this so-and-so customer visited the shop and he did so-and-so activity like this. What are the challenges I may face? The volume of data will be very high. You think like this. If I type a passage of content means how much big sized data it will be generating. If you want to just do some sort of filtration or processing, it is very hard. All these are the challenges what we may face if I store the data like this. Hey, Irfan visited the shop. If I type something like this, visited shop 1 that I'm owning at 10 a.m. If something is being typed like this means the size of data will be increased like anything, because I put lot of characters in between. So Irfan visited shop number 1, and I may not follow some regular strategy. No predefined framework of storage and retrieval of data I follow, right? Everything will be in a kind of an unstructured format. There is no structure I'm following, right? Everything will be in an unstructured format, and there will be duplication of data. It is very hard for me to filter and process it. If somebody asks, hey, can you tell me yesterday what is the sales happened in your shop? I have to go and understand each and every passage of what I have written. And then I have to say, oh, okay, this is the total amount of sales that happened yesterday, right? So a lot of challenges I may face. There is no methodology to process this data, which is a big challenge what they faced in the year of 1960 plus and all for about a decade of 10 years. Then they introduced a better way of managing the data in the name of DBMS. What is DBMS? Most of you guys know, which is nothing but database management system. I'm talking about how this big data got evolved, guys. So database management system is nothing but what you know has been introduced like an Excel sheet. You can consider, you know, MS Access or MS Excel and all, right? You can consider like an Excel sheet. So DBMS can be considered like an Excel sheet. In the year of 1970 plus and all, in order to manage the transaction information, there is something called DBMS has been introduced. DBMS is like what? I'll be creating a sheet like this. In this sheet, I may put several columns. So a single sheet with rows and columns will be created. So it contains the customer name, customer called A, right? Approached, you know, like a store called S, or leave that store. He purchased a product called, the product called X, and he purchased with an amount of 10 paisa or whatever it may be, with a quantity of 1, right, in a particular date period, right, of yesterday or today or whatever the date I'm going to mention. So this is how the data is going to be mentioned, which contains the customer information, the product information, and the transaction information. There are 3 information I'm going to maintain: customer info, product info, and transaction information. When this transaction got happened, all these 3 information I'm going to maintain in a single view, in a single table. Maybe the customer name, customer address, and the city and everything might be also added over in this table. You can see it in that way. So I'm going to add the product description and the customer address also in this table. So the customer address is XYZ, which is of 100 bytes in size. Product description is ABC. So you have to accommodate this much content in this data set, right? Again, customer name B is approaching. He is purchasing a product called Y with the amount of 5, you know, like whatever the 5 paisa or $5 yesterday, again in the same date, where the customer address is going to be, you know, like something like XXX, and the product is going to be YYY, some description he has. And again, the customer A is coming back today. and he's going to purchase a product of Y with the amount of 10 paisa with a quantity of 2, and he's going to return the same customer name, address XYZ only, and he's going to have the same maybe the product description might be YYY. Guys, what I'm saying here is I have 3 transactions happened yesterday and today. I have 3 transactions happened by the 2 customers. Customer name is A, customer name is A. So yesterday this customer A came to my shop and he purchased a product called X for an amount of 10 rupees or 10 paisa with a quantity of 1, and in the day of yesterday with the customer address given as so and so address and the product description given as so and so description. What is this product about and all? Product name alone is being given as YX, but the product description is a big description. It is being given. He purchased some product of chapel, right? He used to mention what is the size of the chapel and what is the category of the chapel and everything. Okay, then the customer B is approaching my shop and he is purchasing a product called Y, right? I'm selling maybe bag to him. So he'll purchase the bag for 5 paisa with 1 quantity. Yesterday he came actually again. But the customer address of B could be something different. He's having a customer address of XXX, whereas the customer A has an address of XYZ, and the product YYY he have a description. I'm not typing the product description, but I'm just showing you guys on the way. And again, I'm having the same customer A is visiting. He's again giving his same address information, but he's purchasing a different product. So the product information is also being stored. He purchased the product Y, not he's now purchasing today the bag again. For Y is bag, okay. He's purchasing 2 products, maybe 2 quantities purchasing for 10 paisa amount. So there are 3 transactions altogether happened, is stored in a single table. We call this as a kind of a denormalized data storage. So the data is stored in a denormalized fashion. We call it as denormalized. What is this denormalized and all? You guys will be understanding. Every data will be in a flattened format. It will be having the duplicates. So if you just look at this, you can see it occupies more size. So it is going to have duplicate data. How? See, I'm already having the product, the customer address called XYZ, the customer name called X, or customer name called Y, customer name called A, and a product called Y, which is getting duplicated twice here. For every transaction, I'm duplicating the product name. For every transaction, I'm duplicating the customer name. For every transaction, I'm duplicating the product description. For every transaction, I'm duplicating the product, the customer address also. You got an idea? This customer address XYZ is repeated 2 times. So I'm getting duplicates data, right? So it is not, cost effective. It is going to occupy more space. So the space management is not right here. The volume of data that is generated again is also going to be costly. But this representation of data is better than the unstructured data what I have. Rather than just doing some processing on this unstructured data, which is very hard for me to do. But here I can do a filtration and processing of the data. But I have a huge duplicate data in this data set. And I have a limitation of scalability. Not scalable. What is scalability? I can't expand from 50 columns to 500 columns. It can support only up to 50 or 60 columns at that point of time. If I wanted to expand this number of columns to 5,000, I'm capturing 5,000 attributes here. Attributes means as a customer name, I'm capturing customer age and marital status or address or location or education category or job category. All this, if I'm going to capture for every items, right, like product or customer or store information or geographical information, if I'm going to capture all this and try to expand this table to a more extent, means it will not be supported. The DBMS will support to an extension of only a few number of columns. So it is not scalable. Scalable means I can't expand to more than several limit. I may have up to 50 columns, not more than 50 columns. If I want to have 500 attributes to be stored, it is not possible for me to store. Even in terms of the number of rows also, the DBMS may support, like I can support 10,000 transactions. What if I want more than 10,000, right? If I want to store, if I have a transaction happened in my business, which is going to be 1 million, I can't store 1 million records in this single Excel sheet or in a single DBMS platform, right? So there are the challenge of scaling. Scaling means expanding the capability, right? Horizontally or vertically. Horizontally, if you are going to increase the capability of an Excel sheet, means what you will do? You'll add more number of columns. If you vertically add means you will add more number of rows. These two are restricted at the time when the DBMS was being managed in the year of 1970 plus and all. The main challenge is duplicated data. What is the duplicated data says? I just have the data in a duplicated fashion. The customer address is getting repeated, the product description is getting repeated, the customer name is getting repeated, the product name is getting repeated. Only the change has happened in the amount and the quantity. For managing this amount and quantity, I'm maintaining the address and everything also, because each and every record I'm capturing the customer address. It is unnecessarily increasing the volume of data. It is unnecessarily having the duplicate data also managed. So what is the challenge I may get if I try to update this data, or if I try to select this data? I may get a huge challenge. What is the challenge I may get is, if I try to update by saying, hey, this customer have changed his address from XYZ to XYZ1. He changed his address. What I'll be doing, I'll update one address, two address. So these two records will get updated. This record and this record will be getting updated. You understand? So I have three customer address, right? Let me just put customer address alone here. We have XYZ, XXX, and we have XYZ again. If I do an update by saying, hey, change the customer address from XYZ to XYZ1 for a customer called A, right? It will go and update the first customer information over here and here also. Two records will be getting updated. So I do update means it will update all the possible data which is related to the customer A. I don't have to update in this way. I can update only one value. It will be reflected everywhere. If I have such an environment, I'll be feeling happy, right? But DBMS will not provide you an opportunity to perform such kind of transaction. When I select also, right, it is going to provide me all the data in one view. But however, I'm unnecessarily seeing the data fetched from this storage, whatever this customer address or description of the product will be transported across the network to see it in the screen. So YY will be transported and YY will be transported and shown two times here. If I want to see what is the product description of the product, what the what it has for Y. The product Y has what description if I want to see. It will show me all these products, all the same description repeated again and again. So if you have the data in a single view like this, right, you may have the data in the format of denormalized fashion. We call it as a denormalized data like this, okay? And if you have the data in a denormalized fashion, there is a chance of getting duplicated data. You see here, you may have the same product name repeated multiple times. You see the same customer name repeated multiple times. We can't avoid that. So the duplication we have to handle. If the duplication increases, the volume of data will also be high. Unnecessarily, I'm spending cost for the storage. And it is not having a scalable feature. That means I can't expand this capability from 10 to 100 or 1,000 to 10,000. It is very hard for me to scale it, to expand my capability from one level to another level. So these are all the challenges what we were facing when we had the DBMS system available. So that created a necessity for me to move towards a different system, different approach. That is RDBMS, right? So if you are clear about this page, what I discussed, let me just clear all this in the screen and I'll go with what is RDBMS. I hope you guys understand what is traditional files and what are the challenges you faced in the traditional file. It is very hard to get it processed because all are in an unstructured data type. We could not able to process them. It is very hard for me to do. Since I'm typing everything as a kind of a mere text, right? I could not able to handle the voluminous data. Since the data is in an unstructured format, it is very hard for you to manage. So I drifted myself, or the requirement made me to drift towards the way of storing data in a DBMS way, table with rows and columns, right? If I keep every data in one table, what is the challenge I may face? Which is called a denormalized data set. If I have the data in a denormalized fashion, I may have huge duplication of data. I may have the volume or the size of data increase like anything. If the volume is keep on increase like anything, I can accommodate only to an extent, not more than several extent. I can't put more million of records or 500 plus columns in a single table, in a single file or in a single table. So DBMS has that limitation at that point of time. Originally it was introduced. If I want to update a record set, I have to go and update not one record, I have to update multiple records because it is duplicated. All duplicated data has to be updated. These are all the challenges I was facing when I was doing with the DBMS, right? So that made me to change my mind saying, hey, DBMS is not going to work for me for a next future and all, right? Because I'm started getting a lot of data in my system, right? If I want to scale it, if I want to have everything stored in a single table, means that is not possible. And it is taking very longer time for getting it processed. In order to update a customer address who is standing in the queue, if it takes 1 minute of time, means I have to make everybody, rest of all people, wait for a minute to get an address updated for one customer. I don't want to engage those and all. Let me just take a different approach. Let me think about something differently. Like this, the things made people to think about, right? So a person called card, right? You know, like something called card rules are defined. Okay. So a person called CODD, card, who have introduced some concept of defining something called normalization. I don't want to talk much about it, but just I'm telling you. There is a person called card who defines several rules for normalizing the data. The table, whatever we have in a denormalized fashion, like a single table, which takes care of all the data in one place, right? I'm going to split these tables into multiples, like customer table I'm going to split, product table I'm going to split, transaction data I'm going to split. So this split I'm going to do, that is being defined by whom? A person called card. How to define, how to divide this one table into multiple tables, right? That is the concept of relational database management system, which is all about what? I create relation between the DBMS tables. So relational database management system. Relational database management system. We have the DBMS already. I create relation between the tables by splitting them into multiple smaller tables, not having everything in a single wide table. I may go and have multiple small tables or a narrow tables. So he introduced a narrow table concept. Already it was in a wide table format. Wide table means every data will be in a widened format. White table concept was there, originally available, but this guy have introduced how do we normalize the data and make it as a kind of a narrow tables. Narrow tables means what I'm going to talk about. Are you very clear about what I spoken so far in terms of like traditional files and DBMS? Anybody having any questions, guys? Shall I rub this screen?
Yes, sir.
Yes, sir.
You are good? Thank you. Thank you, guys, for your response. Okay, let me just clean the screen and I'll just go with what is RDBMS. You don't have to worry, but you have to at least know something called DBMS, something called RDBMS was there. Okay, or even RDBMS still exists. I'm not saying, guys, we are going to throw away RDBMS, we are going to throw away maybe data warehouse. We may lean down, we may reduce the usage of it. There is a big confusion people used to have, but that part you are going to understand soon. Okay, so give me some time. Okay, RDBMS. RDBMS represents what? Relational database management system, as such I told. It is relational. Okay. So what I'm going to do, rather than having a single table of, all in one place, I'm going to create multiple tables. What are the tables I'm going to create? Let's see. So I'm going to create customer table. I'm going to create product table. And I'm going to create transaction table. So all widened tables are narrowed now, right? Transaction tables I'm creating. I'm creating a product table. And a transaction table I'm creating. Okay. So in the customer table, I'm going to retain customer ID. I'm introducing a column called customer ID, customer name, and address. Let's retain only these three fields for now. But if this table says I can support up to 500 fields or 200 fields, it's fine. I'm going to have only maximum of 200 customer information. Even though if I have more than 200 customer information, right, or attributes, right, I can create one more customer table called cust1, cust2, cust3, and I can expand and go at any level, right? So you have a capability of expanding. But however, let's have this customer table is getting created, which contains customer ID 1 and 2. The customer name is going to be A and B, right, what we created earlier. So A is the customer name, B is the customer name. And address is going to be XYZ or something like I'm just creating XYZ1. The customer address is XYZ and XYZ1 for these two customers. Okay. And the third case, the second case, product. You have product ID, which is a running number, sequence number, maybe 10, 20, we can have the product IDs with. So we have two products, let's assume, let's go with some minimal data. Product name, product description. So product name is going to be X and product name is going to be Y, and the product description is going to be ABC and ABC1. We have like this. Let's assume it that way. Then we are going to capture the transaction data, which is going to be transaction ID, product ID, customer ID. Then I'm going to maintain the amount, quantity, and the date. The date of purchase. All this information I'm going to maintain. So how many transactions are being made? 3 transactions. What is the product ID? Initially he purchased for $10. I mean, the product ID 10, the customer A have purchased, right? Which is nothing but, I'll be putting the customer ID 1. Then the customer ID B have purchased product ID called 20. He purchased Y, right? So I'm putting 20 here. And again, customer 1 have purchased the same product called 20. The product ID 20, the one also have purchased. So now I'm going to maintain an amount of, he initially purchased a product 1, right? The product ID 10 with an amount of $10 of quantity 1. And this guy have purchased one quantity of the same product 20 for $5 or 5 paisa. And the person 1 again, that means the customer ID 1 again have purchased the product of whatever the 20 with the 20 product ID he purchased for how many products? 2 products he purchased for an amount of 10. So in whatever the date, yesterday and today, let it be. Okay. So I'm not maintaining his address again and again here. I'm not mentioning the address of the customer or the product description of the same of the product here. I'm not mentioning the customer name over here and all. So if I mention all over here, then it is going to be a duplicated effort, right? I'm just reducing the duplication. See, I'm maintaining only the transaction in a separate table, and I'm maintaining the customer address only once for all, product description only once for all, and the product name once for all. But if I want to see the holistic view of doing this data, if I want to see this output in a holistic view, like a wide table. So these are all narrow tables, right? I created or I just performed a relational table creation. Relational means I can just create or split the tables into multiples and I can relate them whenever I want. So this is a table number 1, table number 2, and table number 3 what I have. I can simply join these tables by writing a join query. So when I join all this table, I will be seeing the same view of what you have seen earlier. What you can see is, we can see the same view what we have seen earlier, right? What is that? Customer name, address, product name, product description, amount, quantity and product, quantity and date. You guys can see all this output in a screen just by doing a join. So product description will be displayed how many times? Multiple times in the screen, but actually how many times it got stored? Only once. So the product description is stored only once here, right? If I purchase this product 22 times means it will be shown 2 times here. Maybe ABC1 might have been shown 2 times here, right? Because a customer, one have purchased 2 times, right? Or customer 2 have purchased 1 time, 1 have purchased 1 time. So the product description may be displayed 2 times when I do a select. But how many times it got stored? Only 1 time. You can see only one in the master data. I have stored it only once. So we are using a kind of a master detail architecture. This is a master data. This is a detailed data of that master. We maintain only the transaction data in a separate table, and all the master data, the dimension data or master data will be maintaining in our other tables. So what happens? You can maintain only this description or address and everything only once. Now a customer is approaching me saying, "Hey Irfan, sorry, I changed my address from XYZ to XYZ2. If he's saying that way, I have to go here and update only once. How many times I'm updating now? Only once. One record will be updated by saying what? Update set address equal to XYZ2, where ID equal to 1, customer ID equal to 1. If I say that like that way, only one record will be updated, not not 2 times or 10 times, whatever the customer one have transacted 100 times also. Earlier in the case of DBMS, it will be updated 100 times. Now it will be updated only 1 time because it is stored in a separated table as a master data. How I can connect this customer data with the transaction data? I use the ID. I use this ID to connect. So this, in order to understand really, you have to know what is join in databases. Maybe whoever does not have a knowledge of what is database or tables or joins and all, at the time when we discuss about this in a later point of time, you will get a clarity. But for now, you try to understand, I may use this customer ID to join. This customer ID will help me to join these 2 data set, and I can just get a view of what is the name for the customer ID 1, what is the name, what is the address, what is the the amount he purchased, what is the quantity he got, in what date he got it. You got an idea? Everything can be expanded and seen by joining this customer ID. If you want to know about the product also, then you have to join with the product ID also. Based on the product ID what he has, 10 is the product ID. I can just expand what is the name of the product also, right? Okay, what is the name of the product also? You can just able to get out of here, right? By using what? Product ID as the join condition. You have product ID, right? You can join based on this ID 10 over here and expand if you want the product information also to be seen. But I'm saying I don't want the product information to be seen. I want only the customer information to be seen. I can see that. You are not storing it this way. You are retrieving back in this way. Then you can call it as what? You can call it as a relational database management. Relational database management means you are relating as per your need and getting the data managed. This is all about relational database management. So the DBMS to RDBMS shift has been happened in the year of 1980 plus and all, right? After the definition of something called CORD rules or normalization, we call it as a normalized data. This is called normalized. Database deals more about normalization. Earlier it was denormalized, right? It is normalized now. You can see it is normalized. Okay, we call it as a normalized table. Leave that part for now. Okay, you are finding everything good, right? Then why there is an introduction of data warehouse happened or distributed systems and all have happened? Why? It looks like good for me. What are the issue? Originally I had to manage the unstructured data. What are people are keep on typing? That has been modified by adding DBMS. But I found in DBMS, I found a lot of challenges in terms of duplication of data, in terms of managing a large volume of data in one table. It is not possible. In order to scale, expand horizontally or vertically, it is very hard. All these have been addressed by the RDBMS. True. But what are the challenges RDBMS faces, right? Okay. RDBMS have some challenges in terms of having the data in a diverged fashion, right? True. Shanmu Pranav asked a question. Retrieval of data is faster in the denormalized data set. That is true. So I'm finding some of the participants raise their hands. Prabhu Ramalingam have raised your hand. You have any question, Prabhu? Okay, I'm just lowering your hand since you don't have any question. If you guys have any question, you can upfront ask me. Don't have to raise the hand and all. You can just ask me the question. If you don't understand, just stop me there itself. Don't worry. Okay, just don't hesitate to stop. Okay, fine, guys. So normalized data, we are getting it formed. So one of the question asked by like Shanmugam, right, saying, hey, denormalized data means it will be faster for access, faster for retrieval. True, it is faster for retrieval, but we can create a denormalized data in the data warehouse platform. That's the reason data warehouse have created a faster retrieval of data. But this DBMS is not for retrieval. It is more for transaction. It is more for storing the data, accepting the data from the customer. It is not for retrieving back and see what is my business, how it might happen, or what is the profit and loss and all. That is also there. But primarily, the DBMS, RDBMS and all are created originally having in mind to accept the transactions from the customer, not to revisit the data back, right? But initially, they were thinking about, let's capture all the data. Let's capture what they're doing. I want a reference of what happened in my business. But they did not think about how can I retrieve and see this data more efficiently, right? They only think about, let's onboard the data first. That is where the traditional systems or traditional file system or DBMS and even RDBMS were thinking about. But after when the time keep on goes, right, they had a problem of revisiting the data. They have the data available in databases, but if they want to revisit, they had the challenges. They find the challenges faced. So what are the challenges we found in RDBMS? I just want to discuss. right? RDBMS accept mostly POS data. It is used for OLTP systems. We have to understand about what is OLTP overlap for that purpose, okay?
So can you hear me?
Yeah, yes.
I have one doubt. So you said that de-normalization data will have lot of data in one table, right? How it is possible to retrieve very fastly, because it has lot of data, right? Fetching from there and showing the details, or fetching the details will get delayed, right? So
Yeah.
how would it be very fast?
Where you are saying in the RDBMS way you are saying?
In traditional files.
Definitely it is hard. In the traditional files, it is not so easy to manage the data or to process it or to retrieve it back and see. We don't have a defined way. We can't write a query. We have to go and manually open the file and read out all the each and every passages and understand. So that's
Sorry,
not so easy.
I was asking about this denormalized data in DBMS.
Okay, how denormalized data will be faster? That's what you're asking.
Yeah, yeah.
Okay, simply say, if I have the things scattered here and there, right? If I want to revisit the data, right, it is hard for me to see the scattered data, get them connected and see. But if everything available in one place, it is very direct for me to see just by writing a query saying select star from table. So DBMS will be helping you to retrieve back and see the result in a much faster way, as Shanmugam is saying. That is true actually. So that is where the reason behind in the data warehouse platform, we have the data both in the format of normalized and denormalized. Got an idea? But originally, if the data is in a denormalized fashion in DBMS, where we do more transaction, then denormalized data is not going to help me. If I keep every data in one place, if I try to put more transaction in the table, it is going to be costly. It is not. So what I'm saying is the DBMS is good for retrieval, not for storage. But I use DBMS for storage most of the cases. It's not good for storage, but it may be good for retrieval of data. But in the DBMS platform, I may prefer more of storage rather than retrieval. Got an idea? In that aspect, though DBMS have a feature of saying, hey, every data available in one place, right? I can just manage, like every data in one place if you say in that way, right?
Yes.
So you can just say you have a better performance in terms of retrieval, but I'm not going to use it for retrieval purpose. I'm going to use it for storage purpose. In terms of storage, if you consider, DBMS is not a right candidate for doing.
So since all it is in one place, it's very easy to fetch the data.
That's what simply I would say, as per Shanmugam said, right, that is true actually. The data is in a denormalized fashion available in one place. You simply say select star from table and you will get all the data. You don't write join. You don't have to think about defining indexes. You don't have to define about proper, there is no skew happen in the join. You don't have to think about bringing all the data into one place and get them joined and shown. Nothing you have to do. Just pull the data, whatever is available.
Yeah, from one table. Yeah, got it, sir. It's clearly understood. Thank you.
But still, it requires some more time. This normalization, denormalization and all, we still have to get matured of understanding. Just I'm telling you, initially, but this is not meant for retrieval. This is meant for storage actually. Originally, they were thinking about, hey, I want to capture the transactions and get them stored. I'm not bothering about right now retrieving and getting some business insight out of it. I don't want to generate report upfront for now. Let me store the data. Let me think about the reporting at a later point of time. Like this, the systems are being initially evolved. Then later they had a problem of saying, hey, we have a lot of data grown in my system. I want to take some valuable insight out of it to serve my customer better. In that case, what they were facing, they got the problem of retrieving back and seeing. At the time, they drifted to the next levels. That is the data warehouse level. Got an idea? Fine. So are you good with this table structure, what I wrote, guys? Any questions here? Let me go and delete this and talk about RDBMS challenges what we have. Any questions here?
Good. I'm good.
Fine. If you guys have any question, please feel free to ask. Don't stop. Okay. These initial understandings are needed here. Okay. So let me just go and, discard these changes. Right. Let me go back. Okay. So let me just talk about, maybe this could be known by several people, guys, but I just want to give it as a recap or anything else, because we want to start with how this big data got evolved. What made the necessity of inventing big data? I just wanted to bring that over here. That's the reason I just talked about all this. Don't think like, hey, why he's talking about DBMS, RDBMS, and all. I know about it. Fine. You'll be getting a clarity on all this after this. Okay. So RDBMS, Relational Database Management System, which will be used mostly for the point of sale system in the name of OLTP. online transaction processing. If you guys haven't heard about this terminology, point of sale or OLTP, let me talk about it. So online transaction processing. Okay, so this RDBMS are meant for performing OLTP activities, which will be generated, the transactions will be generated by the point of sale system. Point of sale system means you go to a shop, they retain a database for storing all your information. You go to a point of sale where the sale is happening. You purchase a product, the product information, who purchased, when purchased, or what he purchased, how much he purchased, from which store he purchased, every information will be stored in this RDBMS. Through the point of sale system, they used to get the data. Every activity that is happening, every event that is happening, or a transaction that is happening in the point of sale system will be registered as a record in this RDBMS table. We call that activity as OLTP, online transaction processing. In the online means don't think about online that we are seeing in the website or whatever it may be. It could be anything that happens in real time, that happens in online. That activity is going to be more of transaction. Transaction means some action you are performing. You are purchasing some product or returning back something, or you are doing some activity, right? Which could be anything. I don't mean it, right? So when you do some real-time transaction activities, right, which has to be processed, in the sense it has to be accommodated, it has to be stored, it has to be updated, it has to be deleted, or it has to be retrieved also. Anything that is happening in the real time has to be performed with an activity of insert, update, delete, or selection. It may have to undergo with any of these activities that happens in real time. So we call it as an OLTP system. So usually the RDBMS systems are being formed considering OLTP in mind originally in the year of 1980 plus and all. But in an organization, even if you guys say in your organization, how many databases are there? Can you say we have Oracle database, we have Teradata database, we have MySQL database, we have DB2 database. Every database you can see in an organization. Hey, everybody are going to store the data in a single storage called database, RDBMS. Why they are maintaining this many number of databases? Based on their requirement, based on their use cases, they may just go and buy several databases from different vendors and they will make use of it. Not every database serves all the single purpose. In terms of size or in terms of the performance, in terms of the latency, in terms of the throughput, lot of terminologies are there. Let's discuss on that later. But every database may not serve all the purposes. So in an organization, in a single company, maybe let's assume my company is Amazon. Okay, I'm owning Amazon, right? Amazon may have all these databases available. So, but in the, for Amazon, you are the only customer. Irfan is going to purchase some product in Amazon means Irfan's information may be stored in different databases. Maybe what are the databases? Let's assume. In this database, Irfan marketing information is going to be stored. How Irfan have made this purchase happen in Amazon? Through directly he came to the site, or he came through some marketing channel. He clicked on some ad and he came here. Teradata is going to store, the service-oriented information, the repair tickets what Irfan have created. He contacted the call center. So the call center agent have provided what response to him. That information will be stored in Teradata. Or he's doing some transaction activity. He did some purchases, right? So ordering or purchase he did. That is maintained in a different database. And DB2 is maintaining the billing information. Irfan has subscribed for, Amazon Prime. So month over month or year over year, I have to send him the bill. I have to manage his bill. If he have consumed more means I have to spend, I have to cost him more, I have to charge him more. This will be managed by a different database. So there are 4 databases, just I'm talking as an example. Amazon maintains 4 databases to maintain the information of Irfan. The same customer called Irfan's information will be maintained in different aspects. How Irfan have been acquired to my system. What is the bill that is being generated to Irfan? What is the repair tickets Irfan have raised with Amazon? What are the product he ordered? How the delivery, shipping have happened means that I have a logistics department separately. So in a single organization, you see lot of departments lot of portfolios, lot of departments. Every department has their own databases maintained. You understand? So a single database, a single system, a company has multiple databases maintained. So if I keep all this data in different databases, because I have a restriction in a single database, I can't put all the data. Why? Because the database could not able to handle that much volume of data. So I'm creating, I'm buying multiple database instances and making use. So what is the big challenge we have in the RDBMS platform is the data is diverged, which is a big problem. Diverged data availability. Maybe we can address the problem of deduplicated data. The data is in a deduplicated fashion. And the RDBMS is meant for performing OLTP, more for transaction, more for performing online transaction processing, not for analysis. The data is diverged, guys. It is kept here and there. If I want to know about how many customer, undergone with, repair, have, churned out. That means I want to know an understanding of a customer is getting into a marketing channel. Through the marketing channel, he is approaching the provisioning channel. Provisioning channel is ordering channel, and from the ordering, it is being provisioned to him. The customer undergo with the repair, so he is going out of the company or churning out. We call it as churn. Churn means the customer leave out of the company. So marketing team put their best effort to bring the customer. Ordering team have provided a best effort for enabling the order for the customer. Provisioning team have provisioned the product to the customer. But after the customer received the product, he got into a repair. See, he got a product not performing well. So he's raising a repair ticket to the customer, to the call center. The call center is not fixing the problem in the defined time because they are giving the same priority for all other customers. But this guy have purchased today morning. Today morning, the customer have purchased a product and it is being provisioned to him today morning itself, but he got into an issue by afternoon. So he's thinking like, hey, what morning I purchased a product, there is some issue happened in this product. If I call the call center and ask them to fix the issue, they are saying, wait for 2 days, we'll send our representative to get the product fixed. I don't want this company. I don't want to, work with this company or make use of this product. Let me just come out of this. Let me just return back this product. Let me just close the association what I'm having with this company in terms of this product, right? You purchase a TV from Amazon means if they say in that way, hey, whatever the TV we delivered, it is not working. Immediately you expect a replacement. If they say, no, wait, we will serve we have a lot of other customers lined up, right? We'll serve them and we'll come back and help you means, in your situation, you will not accept because right now I purchased a product. Maybe those customers might got a product 1 month before or 1 year before. You are servicing them means that is fine. You can do a late service for them. But I got a product morning. I'm really in a frustrated mode. I could not able to accept your, whatever the fix that you are going to do. So if I have to get this data connected here and there, whatever the product that is provisioned today, right, has to be understandable by the repair system saying, hey, this product is provisioned to the customer by today morning. So I have to just expedite his repair. His repair has to be done immediately. How the repair system knows? Because repair system maintains in a different database, provisioning system maintains the product the customer information in a different database. If these two systems has to speak means, it will take some time. Even this may take a 1 day delay. If the two systems are disconnected to manage a customer means, right? How can I manage the customer? This is the problem of diverged data. Every data are kept here and there. If I want to stitch all of them to understand what is the real problem the customer is facing, it is very hard for me if I maintain databases. So for analyzing the data, whatever I got stored, it is very hard if the data is in a diverged fashion. If it kept here and there, it is very hard for me to manage. Though it is deduplicated, that is a good feature what I have, but it is meant for OLTP. What is OLTP? Only for transaction. Only for onboarding, the insert, update, and delete, right? Not for generating report. I told, right, if the data is kept in different tables, you have to connect and see, which is costly for you. You have to execute join queries each and every time. And let me tell you one more problem what we have majorly available. In an RDBMS table, you are going to maintain 3 years worth of data. Let's assume in that way. Usually we will not be maintaining. We maintain month worth of data, maybe 3 months worth of data I may maintain. Not 3 years worth of data. Why? I just wanted to have my insert, update, delete happens faster. If 3 months data is going to be, 3 lakhs records, it is going to have. Customers are going to stand in the queue in the shop, right? They are going to say, hey, I changed my RR. Can you do this transaction? Can you just build this product, whatever I have in my hand? If I'm going to perform an update or an insert to this 3 lakh record is better, or the 3 years worth of data, if I maintain 3 billion record is better to update or query back. So if the customer is standing in the queue, in the database table, I'm maintaining 3 billion records in the table, which contains 3 years worth of data. Or I'm going to retain only 3 months worth of data in the table. So I'll be feeling comfortable if I have 3 months worth of data in the table, because updating in 3 lakhs records or managing these 3 lakhs records is easy for me in front of the customer than managing the 3 billion records in front of the customer. So RDBMS is not meant for reporting purpose. So if you want to generate a 3 years worth of report saying, hey, today my business is like this, how it was 1 year before, I could not able to generate report with this 3 months. I have to maintain years of data. But RDBMS is not meant for storing years of data. It is meant for storing very minimal data only for transaction purpose, right? Got an idea? So RDBMS is not for performing OLAP. We have another concept called OLAP, online analytical processing.
Irfan, I have a question.
Yeah.
So how RDBMS is not deduplicated? Like the data is there in multiple places, right? I see duplication.
The data is in multiple places. True. What you said, I'm not getting you.
So you said like it is deduplicated. It is duplicated, right?
No. Duplicated in the sense the customer information is kept not in the name of, like, I may have some universal ID, universal customer ID. Maybe like my customer master order number will be maintained. The universal customer information will be maintained in one system maybe, but the marketing related information will be kept by the marketing team. Billing related information will be kept in the billing team. Repair related information will be kept in the repair team. But with respect to a single database, it is not duplicated. Maybe across the system, I'm just maintaining different process and different data of the customer. Marketing team does not require all the attributes of the customer. Repair team requires some other attributes of the customer. He requires more of the product information, not the customer information. But marketing more of the customer information, not the product information.
So if I have multiple applications, there is a chance of duplication.
See, within a single database, if you think, it is not duplicated. But across different systems, if you go, it may have duplicates, but not every attributes are duplicated. Because ordering system may require some attributes, repair system may require some other attributes. They show a different interest. Got an idea? But the customer name might be repeated, maybe. But within the database, you think it is not duplicated. It is going to be segregated and stored in multiple tables. But it is a very hard activity for me to maintain different systems with different data. But that is how it has been happening in the right now market. We don't have a single unified system where everything can be accommodated. Everything are diverged. There is no converged platform that is available. The big data is trending because of I'm converging all this platform into one place. So in few more minutes, you'll be understanding that part, what I'm saying. The convergence of data, how it happens. Okay. So let it be. This RDBMS is meant for OLTP, not for OLAP, not for analytical, not for analysis. It is only meant for a transaction. It is not meant for analytical. So that means what I'm saying is you will be retaining only months worth of data, but with the months worth of data, you can't retrieve reports or do any analysis on it. So RDBMS has a major drawback of only it supports OLTP more efficiently than analysis, than historical data analysis. So RDBMS will not support that more efficiently if you have it as a kind of a OLTP system. And it has a problem of diverged data. But to separately manage the data between different systems, it is fine. But if I want to do a consolidated analysis, a converged analysis, it is very hard for me to do with the RDBMS. So that's the reason the evolvement of data warehouse have happened. Got an idea? Are you clear with what I mentioned in the screen, guys? Any questions here with respect to RDBMS? Any questions anybody have? If you don't have, let me delete this content. Okay. Finally, the drift has happened in the year of 1990 plus and all in the name of, data warehouse. Okay. The data warehouse has been formed in the name of EDW. We call it as EDW, Enterprise Data Warehouse. What is enterprise data warehouse? So all these systems who are all having ordering data, marketing data, or provisioning data, repair data, everything will be sent to one database. Again, it will be sent to one database. Got an idea? In the name of data warehouse, we call it. We call it as a data warehouse. So all this data will be placed in. Give me a second, guys. So sorry, guys. If you just look at this, all the data will be converged into one platform by having something called data warehouse created. Mostly like Teradata or Oracle kind of higher end databases will be used for that purpose. But again, this is going to be a database only. If you think data warehouse is something different, not really. The way how the data will be managed is different. The model how the data will be stored and retrieved will be different. But actually speaking, this is also a database. All this data is going to be stored into another one database for converging purpose. So the purpose of creating database is to perform historical data analysis. Historical analysis they wanted to perform. So the implementation of data warehouse has been created for performing OLAP activities. What is OLAP? Where data warehouse is meant for OLTP, it is meant for saying, hey, any customer who comes to the business, let them enter all their data into RDBMS. But whatever I want to analyze, the data that has been entered in the RDBMS system, if I want to analyze means, let me bring the data to a different platform called data warehouse. Like this is like a store. This is like a warehouse of the store, the godown of the store. All product what has to be immediately served will be kept in the showcase of the store. Whatever can be kept in my warehouse for analysis, for stock purpose, for stocking purpose, and all, I can keep it in my warehouse or the godown, right? The same concept that they have created actually. So historical analysis of data has to be done means, right? They created something called data warehouse by thinking for enterprise wide, for a whole organization, for Amazon, which is an enterprise. Amazon is a retail company or a wholesale selling company, which is called as an enterprise. For whole Amazon, let me create one data warehouse like this. At that point of time, at the 1990 plus time, they were thinking like, let's create one database. Let's create one data warehouse. Let it hold all historical data. Maybe 5 years worth of customer information, let them hold. And let's keep the data in a denormalized format again for performing analysis, right? Again, I'm thinking about keeping the data in a denormalized format. What? Every data will be in a single table. The data warehouse will provide in the name called fact. I'm going to talk about that and that sometime later. The fact tables will be created, which will have every factual information, which will be in a denormalized format again. Like you have seen in DBMS, right? The same kind of data you can see here, the structure you can see here in data warehouse. Because I don't use data warehouse for what purpose? For transaction purpose. I'm using this data warehouse for analysis purpose. So if I analyze this data by keeping everything in one place, right, it is very easy for me to analyze. For query, you guys were asking this question, right? Hey, how if I keep every data in one place, it is going to improve my performance? Yes, true. I'm going to write a direct query saying, hey, can you show me in the past 2 years how much sales I have made, or how much repairs have been created, repair tickets have been created. So I'll create some fact called repair fact. I create something called order fact. I may create a lot of tables by saying ordering related information, repair related information, provisioning related information. Everything I create as a kind of a separate fact tables that can be used for performing historical analysis. Got an idea, guys? This is all about like the data warehouse that has been formed by keeping in mind saying enterprise-wide data warehouse I want to form. But the problem what they started facing is data warehouse also started saying, Teradata says, hey, I can handle terabytes of data. What is terabytes and that we have to still learn, but just I'm telling you, I have a capacity of handling terabytes of data more efficiently. We buy terabyte hard disk, right? Even we are owning terabyte level of hard disk. For us to store our data set, that 2 TB or 4 TB hard disk is not enough. How to store an organizational data, 2 terabyte or 100 terabytes or 400 terabytes is enough, right? So there is a hard limitation that has been set. So the scalability is very limited. So they thought in mind saying originally in the 1990 and all, Let me create a single data warehouse where every data will be stored in a historical fashion. We'll use that for analysis purpose. It was worked for some period of time. But after some period of time, they started creating n number of data warehouses. DW1, can you say, you guys who are all working in the data warehouse platform, in your organization, you may see different data warehouse team and different data warehouses are being created. Why I call it as an enterprise data warehouse means for whole enterprise, I want one data warehouse. That is what the initial idea I hold in my mind, but that was not succeeded. That was a failure story. After some period of time, after 1 or 2 decades, I found not a single organizational data can be stored in a database again. I am choosing a database to store, right? How can I store 10 database data into one database? If I'm that too, the historical data for analysis purpose, it's very hard. So what happened, the problem of, again, the data convergence have happened. They thought of the, they thought of like converging all the data in one place by creating data warehouse. But again, the problem of what started happening in the data warehouse also, the problem of divergence. What is divergence? The data are being again started diverging. In the sense, I have 10 data warehouse or 20 data warehouse for a single organization. Again, to connect the data between the customer from one data warehouse to another data warehouse, it is very hard. That is where again the problem of convergence have happened. Though I analyze the historical data to an extent, not more than that. I could not be able to accommodate more systems because nowadays the companies are having more channel of engagements. Channel of engagements in the sense, customer comes through online channel or web portal or through call centers or through video channels or through assisted audio channels. Lot of channels, the customer interactions are happening, right? Through mobile platform, lot of interactions are happening. To hold all those data, which is generated in different type of format or different, all this DBMS, RDBMS and data warehouse have a big problem of holding what data? Only holding structured data. If you give the data in a structured format, they will be holding it more efficiently. If you give the data in a different format and all, they could not able to hold. Unstructured or semi-structured and all, they could not able to hold. That is the problem what we started facing in data warehouse also in a later point of time. It was working till the year of 2000 in a better way because the volume of data that get generated in the year of 2000 plus and all was not so high. It is manageable. But after some period of time, when the volume keep on increased, one data warehouse could not able to manage. So again, multiple data warehouse start built, which again go to the problem of divergence. Every data kept here and there scattered. I could not able to do a consolidated analysis. So why data warehouse is formed for historical analysis of data in the name of OLAP, online analytical processing, right? The problem what we have in the RDBMS is we can't analyze the data. We can only store and process the data, but we can't analyze. So for that reason, a separate environment called data warehouse has been created. The people from ETL and all, right? You guys are all working in this project of managing the data warehouses, right? Doing some ETL activity. We do an extract, transform, and load on a daily basis. We extract the data from different source, apply some business logic in the name of transformation, and load the data into the data warehouse platform. This is what we ultimately do on a daily basis, but that is not a success story for after some period of time. Why? The data warehouse says we are also using a database. Then there may be a question asked, already from several databases you are getting again to a database, means how that is possible? For that reason only, the implementation of big data has been happened. The concept of distributed system has been introduced in the year of 1995 plus and all, but it was a failure story. I'll talk about what is that failure story and all in the upcoming sessions in a later point of time. What they did, they tried to expand the capability from terabytes to petabyte scale. So they, when the data warehouse seems to be failure for handling more than terabytes of data, right? They thought of creating a petabyte scale storage. What is petabyte, terabyte and all, I'm going to talk in the next week. Just I'm telling you. Petabyte storage level of data they wanted to manage. For that reason, what they did, they started creating something called distributed system. What is distributed? The word, very, very important word. We are going to learn throughout our course for the next 6 months or next 5 months or whatever. We are going to learn only a word called distribution. What is distribution? What is distributed? So if I have a task to be completed in 1 hour, right? If you are giving me a task to me, 20 tasks to me, which has to be completed in 1 hour means by Irfan, I may just do with my 2 hands to complete it in 1 hour. But if you want me to complete it in half an hour, what I have to do, I have to take a help from one more person, saying like, Shanmugam, can you help me? I can let's together work. Let's two of us work in this problem and get it resolved. If the person who is giving the work to me is saying, hey, I don't wait for even half an hour and all, you have to complete this in 10 minutes. Then what I'll be doing is I'll take 6 people help and get the work resolved. If I distribute the workload to more than one person, I'm going to say, hey, this 1 hour worth of work, what I'm going to do, can 6 of you guys do this? So we can complete together in 10 minutes. This is called distributed system. If I just pass this data to multiple systems and get the work done, then that is called distributed system. Altogether, that is the concept. If I simply say like this, guys, I'm going to give you, you have a 2 terabyte hard disk laptop in your hand. If I give you 10 terabyte data, what you'll do? I'll buy 4 more laptops and I'll put 2 terabytes in each and every machine. That is called distributed storage. You got an idea? So such kind of environment has been built in the year of 1995 plus and all, to handle a very large volume of data from different databases. N number of databases you give the data, let me store it in one platform. That is distributed system has been introduced in the year of 1995, but it was a failure story originally when it was introduced. But in the name of Hadoop, when it was introduced in the later period of time, in the year of 2006 and all, that was a huge success story where the evolution of distributed system has been started creating. That is what we are going to see in the next upcoming sessions and all. Maybe in the year of 2005 plus, that is in the year of 2006, when the big data system has been introduced, Hadoop says, what you know, hey, you have the data in a unstructured format, like somebody have put as a passage or whatever the story, I know how to handle it. Or Hadoop says, I know how to handle it. You have the data in a DBMS file format, I know how to handle it. You have the data from 100 RDBMS or 1000 RDBMS, you want to put it into one platform, I know how to handle it. Hadoop says in that way. You have 100 data warehouse systems which has to be kept in one place, and which one you wanted to provide a converged data storage in one place, and the data could be of any type, structured or semi-structured or unstructured. I know how to handle it. The big data system says, Hadoop says, Spark says, whatever we are going to learn says, right? And it accommodates a perfectly designed distributed system. You can't find a single flaw. After we discuss about the architecture of Hadoop in another week or 2 weeks, you guys are not going to find even a single flaw out of it. So next week and all, we'll be fully concentrating on the technology stack, but just I'm telling you, okay? We did not even started about what is big data. I did not talk about what is big data yet, because out of the time, I've taken most of the time today for making you understand what you are going to learn and bring some confidence to you for ensuring like you guys are going to put all this effort for some good cause, for some real achievement of the goal, right? Today, I spend most of the time for that purpose. Maybe next week when you gather, you will be getting an idea about what is big data, what is Hadoop to an extent of, okay? Maybe the architecture, how it works and all, we have to discuss in a later subsequent weeks, but at least you may get an idea of what is big data, what is Hadoop in the next week when we start discuss, okay? Until you guys can bring any questions, or you guys can go through and come back even with a lot of questions, whatever you have. But today we've seen only how the data got evolved, starting from the traditional files till big data. So this is the part we are going to learn throughout. See, this big data, right? This is what the part we are going to learn throughout in our journey of learning. So I'm just telling you, if you bring all, if you just have a distributed system called big data environment is being created, you can handle all this data in one shot, right? Regardless of whatever the challenges you faced, you can handle everything in one place. You don't have a problem of duplication issue. You don't have a problem of scalability issue. You don't have a problem of doing OLTP activity, OLAP activity. You don't have a problem of diverged data stored in multiple places. You don't have a problem of storing only structured data. You don't have a problem of storing only terabytes of data. You can store anything. You just name it. I have any data of any format, of any type, of any size, of any speed in which it gets generated. I have a platform. I need a platform to accommodate, means that is the big data platform. We are going to learn more in detail about big data tomorrow, next week. Okay. So any questions here, guys? So what I discussed here is, I did not talk much about what is distributed system. I stopped here till what is data warehouse. So data warehouse is for historical data analysis, more fully for analysis purpose, by holding all historical data for years. But again, if I try to keep years of data in one data warehouse, that is not enough. So I'm splitting the data warehouse into multiple. So the word enterprise has been removed from here. You had to remove that word enterprise, because for a single enterprise, I don't have a single data warehouse. But originally, when the data warehouse was being started, developed, they had in mind saying, I have a distributed system. I mean, I have an enterprise-wide one data warehouse, but that was not possible. That was not a success story. That's the reason things are getting moved from data warehouse into big data platform, right? This is one reason behind why we go with the big data, but it is not the only reason. This is one of the reasons I'm saying. Okay, we will be seeing a lot of other reasons why big data is trending, why we are going towards big data and all in the next week, maybe subsequent week. I don't find huge time for that to be discussed. So any open questions you wanted to speak out, you guys can speak out, or you guys can put it in the group also, whatever it may be, if you want. Thanks guys, thanks for your comment. You'll be seeing a lot of interesting stories. Maybe I thought of showing you something like very quickly. Even I had, because of I taken this for our other batch. For that reason, I wanted to show you guys very quickly how in a minute you guys can enable the data from Twitter. Just I want to show you guys something like this and all, just by creating like this. For weekday 22 or weekend 33 and all, I just enable this. You can see some UI based tools also like this, drag and drop tools also you can see. You see something called Twitter, get Twitter. With this, you guys can go and bring the data from Twitter, bring the data from some HTTP service which is available in the remote system. So I can just quickly create a flow like this, right? I want to get the data from a web service. Okay, what is web service and all you have to know, but just I'm telling you. So I'm creating one browser called invoke HTTP. I'm going to pull the data into a location. I'm going to put the data into my Linux file system. I want to just enable some real-time data. How I can do that? I'm showing you guys how to get some real-time data pipeline created. Just in a minute, just start count how long it is taking for me to configure this. You are going to take a minute of time. Maybe I'm going to get some web data. So some web data I'm going to get. This is the data, right? If I refresh, you will be seeing a lot of new data set got generated. This is from a web. I'm just getting some data generated in a random fashion. This data, how do I bring to my machine? From this website, how I'm going to pull the data into my machine? How long it is going to take? Just see. I'm going to put it into my Linux file system, maybe. So I'm going to put this data into a location called web data. Okay. Let me show you guys there is no web data available right now. There is no such file or directory. Once I start, say, pull this data. One more minute, guys. Okay, I'm going to finish. This is a big data platform what we are working right now. You can see web data location got generated. You are continuously seeing what? The data got generated here. You got an idea? These are all the JSON data, semi-structured data got created. Database says, no, I see if I have to enable this data into database, how much activity you have to perform. See, with the help of this tool like NiFi, how fast I have enabled this data from a web service. So if you want to know how many data sets are available in this location, right? Okay, you got this data available in this storage, but maybe in the JSON object it is not showing. But however, you guys can see how much volume of data got just onboarded in a very short span of time, right? So this is where one of the use cases and all we are going to see in a later point of time. Just in a minute, I enabled the data. You just see that. That is the feature of big data, guys. So any questions you guys have? Okay, guys, I'll be providing you the recording session as such I told, right? Usually like in the classroom session, we don't provide the recording session, but since it is online, we wanted you guys to maybe use this recording session for revisit of what we discussed, not for, not for learning it from scratch. So if I find a number of people attending today is around 65, once I start giving the recording session, you should not think like saying, hey, let me just look at the recording session sometime later. Let me not attend by 9 o'clock, 9 a.m. when Irfan starts. That will really demotivate me. I just wanted to put that caveat before I share the recording session. So I'll be sharing you guys, but with the caution of saying you guys have to make use of it for in a right way by saying you attend the session for learning, because the way how I interact and provide you the session like this, you will not feel the same thing in the recorded session. The recorded session, you may use it for a kind of a revisiting purpose. If you have some doubt, if you're not able to understand something, you can revisit that recording session for in a particular portion. To be very clear in that, I want to define that and I want to share you guys the recording. Maybe today's session, I may share you the recording from what I have teached you guys in terms of the technology. Maybe what was the introduction and everything I have given. I just don't want to provide you guys for this reason alone. Technology stacks, I'll be providing you guys. Okay. So any questions you guys have?
No, Irfan, we are good.
Okay. Yeah, Banu, we will discuss.
It's good.
Yeah, sure. Fine, guys. So just we did not started learning the technology stack yet. I just given you all the idea of here and there. Let's go and progress in the technical side from next week onwards. Okay. So next week, Saturday morning, we'll be discussing and we'll go with it. Okay.
Okay. Okay.
Okay, Irfan, thanks.
Fine, guys. Thank you. Thanks a lot.
Thank you. Thank you, Irfan. Thank you very much.
Thank you, guys.
Thank you. Thank you.
Attitude very high, and
Thank you,
I
Irfan.
spent the whole day today for making, for setting your attitude towards a very high level. So let's keep this momentum and keep this throughout. And you can see the same energy from me. I'm expecting the same from you guys as well. Okay.
Sure.
Thank you very much for your wishes. Thank you.
Irfan?
Yeah.
Irfan, myself Kandamaran. I would like to know the data which you taken, right? Some website you have taken, right? That is your own API, or how you got that?
I just type it API dot
Okay.
randomuser.me. You just type in your website, you can able to see the data, which is a complex JSON data. We are going to do a project using the data in a later point of time.
Okay, thanks, Irfan. And one more thing, the data, I never worked on data warehouse project. I am dealing with RDBMS until now.
Okay.
Finally, the data warehouse also, any of the RDBMS only will be placed, right? Any one of the Oracle.
Data is also stored in some RDBMS, but which is a kind of a higher end RDBMS, like we call it as Oracle or Teradata or Exadata, like those databases may be used. DB2.
Okay.
I will be touch basing with the data warehouse also in a later point of time. So all you guys will be aligned to one level. You guys are belonging to any background, that is fine. You are going to learn SQL, you are going to learn Linux platform, you are going to learn data warehouse platform to an extent of whatever is needed for the big data to be worked with. I'm not going to make you guys as a SQL developer. I'm going to bring you to the base of understanding all this in terms of data warehouse platform, in terms of big data platform. Got an idea? Don't think you are going to learn everything by spending several months. Okay, but what is needed really, I'll be just going with those with the hands-on based, not with the theoretical discussion like this. Okay.
Thank you.
Okay, thank you.
Irfan, Basha here.
Yeah, Basha.
Irfan, I'm basically trying to understand what is the difference between RDBMS and traditional distributed systems. So in RDBMS, we have different tables for one is for ordering, one is to maintain the maintain several databases, like one customer information, order information, everything, right? That is also kind of distributed, like we have in different RDBMS systems. And what do you mean by actually traditional distributed system? What is
that part I told, right? I did not get a huge chance for making you understand that today. I just the way how I explained till data warehouse, I did not put the same time on making you understand what is traditional distributed system or big data or anything else, because of the time constraint what we had today. But simply say distributed system means delegation of work. In RDBMS, you may have a single server. You just simply think like this, okay? What is a distributed system with a given time? I'll tell you what is that, okay? The data warehouse system, if you take a database, it is an appliance-based hardware. A single supercomputer you can consider. A single supercomputer can process the data of 1 TB in 10 minutes means your computer may process 1 TB in 1 hour, let's assume that. So you have a supercomputer, which is a data warehouse. You have your computer, your machine, whatever you are using, right? Data warehouse is going to process 1 TB of data in 10 minutes means your system is going to process in 1 hour. Which one is better? Data warehouse or supercomputer or your computer? Which one is better?
Supercomputer, obviously.
Supercomputer is better. But I'm going to make your computer much better than supercomputer. How? Supercomputer says I may process the data in 10 minutes of 1 TB. But your computer may say I take 1 hour to process. But with your computer, I'm going to make it process in 1 minute. How? I'm going to create 60 computer cluster. I'm going to buy, like your computer, 59 more computers, and I'm going to form a network of cluster. In the cluster, I'm going to give that 1 TB of data. So everybody will be sharing the workload and they will be executing in parallel. So they will complete in an aggregate of how many seconds, how many minutes. 60 computers I'm going to buy and pass 1 hour worth of data. If one computer takes 60 minutes to complete, means 60 computers take how much time to complete?
So it's basically for processing the data, not on the storage level.
Storage also will be done in all your computer. If I pass 60 terabytes of data, every computer will store 1 TB. So this is the part you are going to learn for 6 months. I'm saying you get it in a day, but just try to understand in a layman perspective. I'm not talking in technology perspective right now, because you will not get it right now immediately. I have to explain about the architecture and everything. You may have a lot of questions in that. Just I'm telling you in a oral perspective. Just answer me this question, right? You have your computer of 60 numbers spread across in a network. You have formed a cluster. We call it as a cluster. How long it will take for you to complete this work of 1 TB data management? 1 minute. Everybody will be parallelly working and they'll complete the work in 1 minute. But the supercomputer will take 10 minutes to complete. Got an idea? Because supercomputer has a limitation of saying I can only do a work of maximum 10 computers in one shot, not more than that. Right? So that distributed system, you have to still understand this word the word distribution you learn till even the last day of the class. Okay, so let's learn about it in a very later point of time. But however, this is all about it. Okay, so once you understand Hadoop and all, you'll get more clarity.
Okay. Thank you so much.
Yeah. Thank you, boss. Thank you very much. Thank you, boss.
Yeah, fine. So Amir, I'm new to this area. Last 2 days before, I know about this from your last batch, Raji. Okay, so Amir, you wanted to talk. Even you can talk with me, but with whatever I have shown you today, right? Maybe like I want to know about your background. What is the technology background you are from? Maybe you can update in the G sheet whatever we have provided, or you can just speak with me. You can call me, guys. I'll put my mobile number over here, or even in the group. I can just put my mobile number. You guys can talk to me or send me chat, WhatsApp chat also. We will discuss even, right? Whatever the question you guys can have, you can raise. I'll be happy to answer you. Okay, but don't worry. As such I told, right, leave out all those mind. But I want to just know about your background also to make you sound better. Okay, you can update in the G sheet also. I'll go back and revisit. So I created the data sheet out of that whatever you guys have shared, right? With this one, I can just able to serve you guys better. Okay. Thank you so much, guys. We'll meet next week. Have a good time in between. Thank you, guys.
Thank you, Irfan.
If you don't
Thank
have
you.
other questions,
Thank you, Irfan. Bye.
Thank you, Irfan.